All right, so this is lecture 3 and my name is Hamtedi, and today we're starting the topic of sets, and what we're going to start with first today is the definition. So we're going to start with first defining what sets are and other types of sets. We have the universal sets and everything. So what we're actually doing is just laying a foundation, and the foundation that we're going to be laying is simply just the beginning of the normal sets, the university sets, yeah. But what we're going to learn today is just high school sets, purely high school sets. All right, so we quickly begin. So what are sets? Yeah, okay, before we define the sets, let us first look at these. These are the things that we're going to look at today. We're going to define what a set is, what a null set is, a singleton set, the representation of sets, the set builder notation, finite and infinite sets, universal sets, power set, and equality of sets. Then after this, we call it a day. So a set, according to, this is according to the definition of high school. It's a high school definition. It's a collection of well-defined distinct objects. Okay? A set is a well-defined collection of distinct objects. I've just swapped the words there, but the meaning is just the same. So the example of sets that we have are this. We have this A, B, C. This is a set of 3 elements. And then we have this set here, which has 1 and 2. And between these two numbers, at least the first set here, which we are seeing here, has only 3 elements. This one has infinite number of elements. Yes, I know you are able to see 1, there is also 2 there, but you cannot manage to count the number of elements that are in this set. I know I mean at high school you are taught to say, yeah, when you see such a set, there are 2 elements. There are no. Here, when you see such a set, it has an infinite number of elements. You cannot manage to count the number of elements that are in this set. Same applies to this set here. You can't manage. So these kinds of sets are called interval sets. Yeah, or this representation of sets is called the interval representation of sets. So we're going to go in details as we proceed. So we start first by defining what a null set is. And a null set, in other words, is just the empty set. Yeah, most of you know it to be an empty set, but it's also called a null set. So these are the symbols of null sets. Okay, let me just mute everyone. All right. Yeah, so these are the 2 symbols that are used for a null set or an empty set. All right, I'm pretty sure most of us know what an empty set is, so we don't need to spend much of our time here. We also look at a singleton set. What is a singleton set? So a singleton, from the word single, is just the same. It's just a set that contains only 1 element. So any set that contains 1 element is called a singleton set. Yeah, it's also known as a unit set because it only contains 1 element. All right, so that is an example of a singleton set. Let me just see what these people are saying. All right. Yeah, I'm going to post it. I'm going to post a video. Yeah, so don't worry. So we proceed. Let us now look at the representation of sets. So sets are represented using different ways. There's what we call the set builder notation. We have interval notations. We have the Venn diagrams and everything. So a set is denoted by a capital letter. Example, set A, set B, set N, etc. So the elements of the set are denoted by small letters. So make sure that every time you are listing a set, more especially when it contains alphabetical letters, make sure that you represent those letters using small letters. Yeah, and then a set itself is denoted by a capital letter. So this is the representation of set. So we can see there we have the descriptive form where you just describe a set to say, for instance, here a set of vowels in the English alphabet. And then we also have the set builder notation. This is how you write it in set builder notation. You say X is such that X is a vowel in the English alphabet. And then when you look at the roster form, this is the one that we normally use. And this is the one that was commonly used at high school. Yeah. So we proceed. So the set of the second part, the second one here, you can see the descriptive form here, which says the set of all odd positive integers less than or equal to 15. This is descriptive. It's just describing the set. And then when you look at the set builder notation here, says X is such that X is an odd number, and these odd numbers are between 0 and 15. But 15 is also what? Is also included. That's the reason why you can see this symbol for equal sign. Same applies to the last part here, the set of all positive cube numbers less than 100. All positive cube numbers less than 100. Okay, I'm going to send the slide. Somebody's saying I can't see what I'm explaining here. They can't see what I'm explaining here. So I'm going to send the slide. You have time to go through alone and also the video. So don't worry, don't worry. Okay. So you can see here. And please note that Zoom has also an option of you zooming what you are watching. So what you can see there, you can just zoom the way you zoom your pictures and everything. You hold your two hands on the phone or yeah, or on your tablet, you can zoom it. You can zoom them in order to see them clear. Yeah. So we proceed. Let us now look at the finite and infinite sets. So when you talk about the finite set, this is a set which contains a definite, rather a number, a countable number of elements. But when you talk about the infinite set, it's a set that simply contains the number of elements that you cannot manage to count. Okay. So finite set, this is how I defined it, is a set that has finite or countable number of elements. And then an infinite set is a set that has an infinite number or uncountable or unlimited number of elements. Hope it's clear, because just from the word finite and infinite, we know their definitions. So you just apply those definitions to the set, to the sets. So an example here that has been given is this. Yeah, so the first one here, we can say this one is infinite. Why? Because it has these dots here. Yeah, it has these dots here, which shows to say the numbers here are going to the negatives without ending. They are going to the negatives without ending. I know most of you cannot see this picture, so don't worry, I'm going to send the slide. Okay, so um so when you look at the second part here, it's also infinite. Why? Because it has these dots this side. So these dots are the ones that are causing this set to be infinite because it's showing us to say the numbers are going to the positive side without ending. They are just going to the positive side of the number line without ending. And then let us look at this one. Why is this one a finite set? Why is it a finite set? Because when you look at it, it's saying x is in set builder notation, and it's saying x is a member of whole numbers, and then these whole numbers are between 0 and 10. Are between 0 and 10. So meaning this set can be listed. So if a set can be listed, it simply means that it's a finite set. If you cannot manage to list the number of elements in a set, it means that that is an infinite set. So here we can manage because these numbers are just one, we have 2, we have 3. You list them up to what? You read 7, 8, and then up to 9. So these elements can be listed. Oh, sorry. This is not the way it's supposed to be. It's saying these are what the our own numbers. I was listing the natural numbers. I'm sorry about that. Yeah. So these are all numbers. Okay, yeah, still the same because all numbers and natural numbers. When we talk about all numbers, we include the negatives, and then when we talk about natural numbers are just positive whole numbers. That's so. All right, positive counting numbers. Yeah, okay, that was correct. I thought this was odd. This is whole numbers. Then what I wrote was correct. So this set can be written as 1, 2, 3. You list it like that. Yeah, just as simple as this. 7, 8, up to 9. Yeah, so you can list it like that. So if you are able to count the number of elements in a set, then that set is a finite set. If you are unable to count, then that's an infinite set. So let us try now to look at this one here. This one is saying x is a real number. X is a real number, or x is a member of real numbers, and x minus 2 is equal to 10. So it's telling us to say x minus 2 is equal to 10. All right. So here we can find the value of x. Then we're saying this is going to give us 10 minus, sorry, this is 10 plus 2, because when you find the additive inverse of these two, you are simply just going to add a 2 to the other side of the equal sign. Some of you say when the negative 2 closes the equal sign, it changes the sign. Yeah, still the same. So 10 plus 2, there you get 12. So this 12, is it a real number? Is it a member of real numbers? If yes, then it's a finite set. Can you count the number of elements in this set? Yes, because this one is a singleton set. How do I know? Because I only have one element here. Yeah, but if the question was like this, x and then minus 2, maybe there's a greater than symbol here, and then there's a 10 this side. So if I find the value of x here, it's going to be x plus 2, which will be equal to, oh sorry, this will be equal to x greater than 12. So this one is not a finite set. It's not a finite set, and it's not a singleton set. This one is a singleton set because this x is directly pointing at 12. There is only one element. X is just equal to 12. But when we say x is greater than 12, we're talking about all the numbers that are greater than 12. So all these numbers that are greater than 12 are numbers. So if we were to write that set, if we want to list that set, it's not possible, but we can write it in interval notation, which will be Let me just write it like this. Okay. Yes, somebody is asking to say, do the different brackets have different meanings? Yes, different brackets have different meanings. That's how it is. Anyway, we're going to learn after this slide, maybe the next slide. Just make sure that you don't miss the next lecture that we're going to have, because we're going to be looking at set builder. If it's not in this slide, then it's in the next coming slide. So just make sure that you don't miss the oncoming lecture, because it's talking about your question. Yeah, so here, if we were to write this x greater than 12 in interval notation, we can write it as x is equal to, you say this, you write this kind of bracket, and then we're going to have 12. So this type of bracket means that 12 is not part of the set, then going up to infinity. So you cannot manage to count the number of elements that are in this set. So this is an infinite set. And this set simply implies to say 12 is not part of the set. We're only talking about numbers greater than 12. If we used this kind of bracket, if this was the kind of bracket that we used, this bracket here is simply telling us to say 12 is included in the set. But if we use this kind of bracket here, these are called open brackets, and then these are called closed brackets. Then when you use the open brackets, it simply means that 12 is not part of the set. Hope it's clear. If you've not understood these kinds of brackets and what they mean, I'm teaching in the oncoming lecture. Don't worry. Let us proceed. Yeah, so this one, the reason why it's a finite set we have explained here, it's because x is only one number, it's a singleton set. Okay, let us now proceed. Let us look at this one. Why is this one infinite? This is what I'm just from explaining. X plus 4 is greater than 12. So when you solve this question, you discover that you are going to have something like this: 12 minus 4, and then this x will be greater than 8. So when you're writing this, you write it like this: 8 comma infinity. So this is an infinite set. You cannot manage to count the numbers that are greater than 8. Yeah. So we proceed. All right. If you're having trouble accessing the meeting, then I think the problem is just where you are, or it's just with your phone. Yeah, but don't worry, I'm going to send the recording. You'll be able to watch it on your spare time. If not that, you can, if you are together with that person, please, you can assist him. You can use the same phone or the same gadget that you're using. All right, so let us proceed. So we look at the universal set. The universal set is simply the what? The set that contains all the elements of all given sets. For instance, when you've been given set A and set B, when you combine the two sets together with the sets that are not in set A and set B, you combine them, you list them together, you form what is called the universal set. Yeah. So this one, universal set, I'm pretty sure most of us know what a universal set is. Yeah. Then what is a power set? A power set is a set which includes all the subsets, including the empty set and the original set itself. It is also a type of set. Yeah, it is also a type of set. Yeah, sorry. If set A is equal to X, Y, Z, and then is a set, sorry, then all its subsets are these. So these subsets, when you combine them, you put them in one set. You combine them, you put them in one set, you form what is called a power set. So a power set is simply a set that contains all the subsets of a given set, including the empty set and the set itself. Yeah. So the power set of A, when you have, if this is your set A, the power set of A is just this. You list all the subsets of set A. Okay. So this PA is the one that denotes the power set. So when you're writing the power set, you just use this PA. So if we tell you to find n of P A, if this is the question that comes to say find n of PA, this simply means to say find the number of elements of PA. So sometimes they will not tell you to say find the number of elements in set A or the number of subsets in set A. No. Sometimes they'll ask you to say find the cardinality. So whenever you find that word which says cardinality of a power set or cardinality of any given set is just simply the number of elements of that set, the number of elements in that set. So the number of elements in the power set of A is, you just count this 1, 2, 3, 4, 5, 6, 7, 8. So meaning these, they are 8. So this, the number of elements in any given power set has a formula. So a formula is just 2 to the power n. So this n denotes the what? The number of elements in the set A, like that. Here we have 3 elements, 1, 2, 3. So meaning while there's n there, we can put 3 and you get the same 8. So if you can't list, you can use this n, this formula here. So you can see this 8 is just the same as that 8. Okay. I hope everything is clear. All right. So two sets A and B, yeah, actually we are now looking at the equality of sets. So two sets A and B can be equal only if each element of set A is also the element of set B. Also, if two sets are the subsets of each other, they are said to be equal. This is represented by that. So when two elements set A also, when the elements in set A are just the same elements that are also in set B, those two sets A and B are said to be equal. Okay, but okay, before I explain the equivalent sets, let me finish with equal sets. So for you to say set A and set B are equal, you have to make sure to say whatever that is in set A is also in set B. Any element that is in set A should also be in set B. If all the elements in set A are equal to the elements in set B, then those two sets are equal. But if the number of elements in set A and the number of elements in set B are the same, despite the types of elements being different, the set is said to be equivalent. So when we talk about equivalent sets, we are talking about the cardinality, meaning the number of elements in two or more given sets. So if the cardinality or the number of elements in two given sets are the same, then those two sets are equivalent. But if the elements in two given sets are the same, those two given sets are said to be equal. Yeah, but if the number of elements are the ones that are equal, that's when you can say those two elements are what are equivalent. I don't know if I'm clear because I'm stammering when speaking, but I just hope that everyone is getting me. Yeah. So equal sets have the same number, sorry, equal sets can have the same number and the same elements. So equal sets, okay, let me just give an example. Let me just illustrate maybe. So if set A is equal to 1, 2, 3. So set A is equal to 1, 2, 3, and set B is equal to 1, 2, 4. And then we have also set C, which is equal to 1, 2, 3. Yeah, I think this will work. So for me to find which sets are equal and equivalent here, for me to know which sets are equal and equivalent, sorry, set A is equal to, we look at the number, when we are talking about the equality of sets, you don't look at the number, but you look at the kind of elements that are in set A and that are in set B. Okay, let me even do this maybe. For simplicity's sake, for things to be simple. Yeah. So set A is equal to set C, because the elements that are in set A are the same elements that are in set C. But if we talk of equivalent sets, these are sets that contain the same number of elements. So meaning set A is equivalent to B, which is also equivalent to C. Why do I say A, B, and C are equivalent? It's because they contain the same number of elements. This one has 3 elements, this one has 3 elements, this one has 3 elements as well. All right. So I think maybe this time you guys have understood, because I was stammering when explaining this, but it's good that I realized quickly to use examples. All right, there's an exercise at the end of the lecture slide. So you guys make sure that you solve it, and then after solving, I want the solutions. Yeah, I've only seen a few people who managed to submit the exercise today, the exercise which I gave you on Tuesday. So only a few people managed to do that. Please, as I said when we were beginning, only those that are serious, those whom I give exercise and they submit, are clear this course. And from the time I started teaching people, I've only recorded one person who has ever failed. Otherwise, the rest of the people have been passing. I take sometimes 20, sometimes 30 students, sometimes 40, depending with how many are willing to pay. Because the reason why I even tell you to pay, at first, before I could start telling people to pay, I was doing these things free. You can try to ask people in Murungush University and everyone around, those that know me, they will tell you to say you used to do these things free. But the reason why I've started telling people to pay is because when I've not told you to pay, you don't usually pay attention. I would go for a meeting and only a few people would come. So for you guys to at least be active, I decided to start doing just to start telling people to pay, and it has also helped me in some way. It's also supporting me as well. And you are not only helping me, or I'm not only helping you, but we are helping each other. So I want you guys to be participating in all the activities that I'm giving you. Participate. And for those that have not yet subscribed to the channel, please subscribe. If you have not subscribed to the channel, subscribe, because there are some of the tutorial sheets. Tutorial sheets very soon will start coming out. Probably next week on Monday, you may have your first tutorial sheet. So what I'll be doing is I'm going to be solving the questions in the tutorial sheets, and I'll be posting them directly on the channel. Meaning, if you have not subscribed to the channel, you will not be seeing those things. Only those that have subscribed will be able to access those things. Those are tutorial videos. Okay. There's a question here. Or which channel? Okay. Let's. I'm sure. I'm sure you see those videos that I mean, after this lecture, I'm going to send this video, and I'm not going to send it directly because they come out very large. So what I do is to help you and to help myself to save my bundles. What I do is I'll post them on the YouTube channel, and then I'll just send a link in the group. So that same link that I'll send, that is the link to my YouTube channel. So just make sure that you subscribe. There's a button there, a red button which says subscribe. Just click on that button so that the time I'll start sending the solutions for the tutorial sheet, you'll be able to access them. Okay. So thank you very much. I don't know if you guys have any questions. You can ask in these remaining few seconds. All right. Going through this again. Okay. I'll send the link to the video. Yeah. Even the notes I'll send, no problem. So don't worry. You have time to go through alone. Okay? Keith, you have a question?
Yes, sir.
Okay.
Yeah, I just want to ask about the no sets.
Okay.
Yes, you explain about them. I didn't get the concept.
Oh, the now set is just an empty set.
It's just an empty set.
Yes.
Oh,
Yes.
okay, okay.
All right. Do we have another question? Another question? Anyway, so you guys, if you don't have questions, I'm ending the meeting. Let's meet on Monday, and please make sure that you answer the exercise and submit before Monday. Submit before Monday so that the earlier you submit, the earlier I mark you, and the more time you have to ask me questions where you are not clear. And the reason why you have not failed, you have failed some of the questions that you are going to fail in the exercise. And I'm glad to say some of you, I'm glad to see that most of you are understanding what I'm teaching, because the response so far from the people that managed to submit the previous exercise was good. So just continue with the same spirit, attend all the meetings that I'm presenting. If you can't manage to attend that, but at least find time to be watching, to be going through those videos that I send, the links that I'm going to be sending. All right, thank you very much for attending today's lecture. I'm going to send the notes together with the link to the channel. All right.